Okay, so we have to continue from what we left, and I'm taking actually sequentially. So whether it is theory or whether it is your lab, won't make much difference, because I, AI is practical basically. So whatever theory is there, we will cover that also. But first we have to understand the theoretical part and how to manage the data. Then we can understand how to implement, because they are all linked. I cannot start theory and then I cannot have the practical lab part. So it has to be combined. So I'll be taking in a way that you can understand and implement also. Okay, we'll be covering the syllabus, so you don't have to worry about that. But anyway, there's nothing much in the syllabus actually. So let's continue now, and we have the quantile function which we will be using with pandas, and for that I have to import. I'll tell you what is quantile. Import I as np, loop few things, otherwise they will just keep on telling me. Okay, 1 minute. Okay, now what is quantile? Quantile actually has come from quantity, that we know that it actually divides the data equal sizes, adjacent subgroups, and sometimes it is referred to as a fractile also, and basically it is the probability area of equal probability finds that, divides and into subgroups and finds uh, quantile of that, or fractile you can say. And I have some data already we used earlier, so let me have that. We used in the last class also D, and let me first print D, and you can see that it is basically data. It's a collection, basically dictionary of series. You can put yeah, dictionary of series I've already put there, and then I have to convert it into a data frame. EP. Yeah. So this is what the data looks like. So series, so we have to convert it into a data frame. So data frame, and the data is in D.
So could you explain the previous code? I didn't pay attention.
Which one?
Okay, this one. Okay, just you have
This
just
is just the
briefly
data,
explained.
data, data,
Okay, sir.
data.
Okay, sir.
I have just actually I used this data earlier also, the last class also, na. So I
Yes.
just pasted from there. This data
Okay,
is
sir.
a name, age, rating. A series is created, and then we will be converting into a data frame. Okay, so
Okay,
this is a dictionary basically, and now
yes.
we will be converting. So we are
Okay, sir.
converting it, and then we'll see what is there now and how it is arranged. Because if it is not arranged properly, then you won't be able to actually work on it. You can see this. This is now properly arranged. It is now tabulated, right? So data frame converts actually into something like your Excel or tables, you can say. It converts into that. Now we have to find the quantile, and quantile may we have 0.2 of each column. So we have to find that. So quantile of each column, I have the command there. So df.quantile 0.2 axis is equal to 0. Just see what happens, and then I'll show you if I change the values. So age is 25 and rating is 3.208. Name, that is not to be there, 0.2, float 64. So age and 3.208.2 for each column. And let me increase this and show you. Can
Sir,
increase or decrease? Yeah.
sir, actually, what quantile function means?
I was telling you. I believe. Quantile actually it's the quantity. It divides into equal size adjacent subgroups, and it is sometimes referred to as fractile also. Okay, so it divides probability distribution. It is a probability distribution, you can say, into areas of equal probability. So what the probability here we are giving is 0.2. Okay, so it probability, you know, that cannot be more than 1. So let's see what happens. Now it is the earlier 0.2 was 25. Now it is 29.50. 29 is this one, fifth one. This is in series 25, 26, 25, 23, 30, 29. So what the probability of that is, and then I can increase it and you can see further. Let me have more of that. You can have 38.80. It finds the average. I'll let me see if I can find the mathematical formulation for this. 1 minute. Huh? Give me 1 minute. There is a mathematical formulation for this also. So it is in mathematics we have quantile. Let's see if I can. Yeah, we have that. I can share the link with you. It is basically a plot. From that you can always find that. Okay. Okay, so this is better. You can understand it this way. And with an example, I'll just put it so that it is the mean distribution, so you can understand that. Let me put it here. Let me put it down so that summarization of data, or I can put it here. Okay. So basically what it is doing, first. So it's a defines particular part of data set, that is content determines how many value in a distribution of data distribution, how many are in a spatial quantile, or the quantile, that is the quantile, fifth quantile or the sixth quantile, 100th quantile, percentile. It is a quartile, quintile or percentiles. Okay. Now suppose example is there, if we divide the distribution into 4 equal portions, we will speak of 4 quantiles. Okay, so it is something like this, and then 5.25, the 80.80, 80%, 50%, and 0.2, 20% is something like this. So how many fall in that? So age and the data. So it is actually, the data is not arranged in such a way that you can actually see much into it. Their names also, otherwise we could have seen more. Let me see the data here. This is the one. So it actually calculates the mean and then finds out how many fall in 20%, 20% of that. Then this is 50%. 50% are like say between 90, 29.50 maybe. So this is not distributed. 29, 30, 34, 40, 31, 51, 46. Okay, about 29, 50% are there. So average of that you can see, and that was 20%. This is 80%. So it has increased. Basically, it finds the probability of the distribution. We have interquartiles also, so you can go through it. And if I can find the formula, it will be better. How you calculate formula, let me find. I share the link. It will be better. You can mathematic can have a look at that. The net is some. I think net is giving some issue today. It is little slow. Okay, I'll share it. I'll put the link there in worksheet itself, notebook. Here is the link. You can have a look at the formulation. Okay, so it's pure mathematics basically. So you can find out how the probability distribution is done. It is something like this. This image is better, I think. If I can put this image here, taken from the link itself, so it's not done by me. It is something like this. Minimum, maximum, Q1, ME, then Q3, quantile 1, 2, 3, something like that. 25, 25, 25, it is equal distribution. And then when I say that this belongs to 80%, how much belongs to 80%? Or how much data is covered in 80%? So you can get the value that this is a average value, and above that or below that, that covers the 80% of the data. So that way you can find out the quantile. It may be required in some cases. Okay. We have another command now, and it finds out. Let's see. And we have okay, so we have pivot. It reshape data frame organized by given index a column values, and reshape data produces a pivot table. We have I have seen this one, but I have not tried with access one. That was column wise. Let's see if I can get it on row wise also. Access 0 or access 1. Yeah, row wise also we can get almost all the data. That is more actually clear. Now point 2 falls, everything falls in that. And if I change it, if let's see what comes. This is mean of that. It finds the mean actually. Now it finds the mean like this. 50% of the data. So age and ratings, it is working on that. Finds an average of it. So the formula is there on the link. You can see the formula. And this is how the distribution is done. Minimum and the maximum. And then accordingly, your mean is found. Okay, now coming to pivot, it reshapes the data frame, index column values, and reshape data based on column values. It depends on the column values. Okay, so we have the parameters, index, columns, values, and that is index is a string or object, column string or object column, then value is string, object or a list of previous optional columns, and change in the also accept list of columns. Okay, there is a change in the version, and then I'll have to see which version we are using. So let's see, returns the data frame. It is actually reshaped the data frame. So pivot would be returning reshaped data frame. Data we already have, so I don't need the data now. The interesting part will be to create TF we already have. So I just want the pivot, name, age, and rating. Then we'll print it and see the type. We have pivot tables in Excel also. So it is something similar to that. Now age, name, and it finds the average of that. Like we have the names here, but whoever falls in that, only those data will be there. Otherwise, everything will be none. Amit is not 23. Okay, so we have 2.56 here, Sumit. I'll have to put the data first. Let me print the data, and you can make the difference. We count the difference. Okay, so this is the original data. That is the name. Name is here, age is here, and the rating. Okay, so the rating is there. 23 in the age group of 23. So it has actually sorted it out: 23, 25, 26, 29, 30, 34, 40, 46, and 51, and summed up. If there are common values, so they will be together. Like 30, 30 is common. You can see 29 also. I think we have more than one value, so you can find that. Now in 23, you have Sumit. 23 single value 2.56. Okay, so it summarizes the data like we do in Excel also. A pivot table, what we do in that is the same, that according to the column whichever we want. Here we have given name and age. Name, age, and rating. Rating will be now name will be on the left hand side. Ages will be your headers, and rating will be distributed. So what is empty will be none, 2.56, and we have common here two things. You can see this. You have 3.2 and 4.8 also. It two, like 30, 3.20 and 4.8. That is 30 Manish and Vikesh. Manish and Vikesh. So Manish is there and Vikesh is there. And you can see that this is also sorted out. So this is also sorted, this is also sorted, and the data distribution is displayed. So whichever, if it is not common, if you have larger data set, then it will be distributed accordingly. But in front of the name, you'll have none if there is no value. So you can change it and the columns and see. You can change the columns and check what we can do with that. And for that, I'll create a small one. I have another data set, and I'll create it directly, which I have a small data I have, and let me print the data frame first. Okay, so ABC, and now I can find the pivot of that. P is equal to TF dot pivot. Not the DF, and, but I have to give dot pivot. We have to give A. We have B. We have C here. And then I can print B. We can find the type also. Print type of P, so that we understand that what the data type is. Something wrong? Yes. TF dot pivot A, B, and C. C is not read now. See what happened, because P is not having a closing bracket. Okay. So you can see Bobby, John, Mina, and data. If it is not there, it won't come. So that will be having none, and then even in Excel, if I create this, then what I get is a blank thing. Okay, and we can have a pivot something like this also. Something like this. We can give pivot index A, columns B, value C A. You can see this out. C A, graduate master, B A, Bobby John Mina. That is values are C and A. That means we have to pivot it on CA, distribute the columns, summarize the columns on CA. The column is B and the index is A. You can see, and the names are distributed there. So it is not a name actually. I've used A for the name. So A is Bobby, John, and Mina. That is name actually. And columns, we are given the degree, graduate, and masters. This is how you can distribute. So you can actually change the things according to your requirement, whatever type of summarization you want of the data, you can summarize. And we have some other data also, so we can distribute that also in a better way. So we have this is a very standard data which is used. Foo and bar, this is coming for a long time. Foo bar bar zoo. This is a very common data set. Foo bar baz zoo and 1 2 2 2 2. This is just the name. Foo has this, and we have strings mostly, and then we have baz which is having the integers. And now if I find the pivot, I want pivot of this based on index and column. I can have one values also. And see that it summarizes very well. You can see this bar ABC, that is columns is bar, and index is foo 1 2. So now it can summarize. You can see that values is bars. So on bars, that is bars 1 2 3 4 5 6. You can see how it is distributed now. So it is better representation of the data now. You can see that. So XYZ we have not included, zoo we have not included. So we have just eliminated zoo because it was not required. It was just something extra. So we are not using it here. So you can eliminate, you can find summarize the data on the columns you want. And if you miss something, then it takes the optional default values. Like this one, we have just given name, age, and rating. So it disputes on that. So it takes the default values if you don't give or miss out few things, or you can always say tell that this is the index, this is the column, and these are the values. And we can have the summarization in different way also. We have something like if I take the bars out, I can put something like this, columns and bars. You can see now the different, you see that now zoo has come because I did not give the values as bars. So nothing happened as such. You can see that the distribution is the same as the default. So if I give inside, then it's okay. Otherwise, can it can be out. And if I give zoo also, as in zoo also, then the summarization is not there. You can see that foo and bar. Better will be that I don't give us an integer as such. Okay, let's see. If I give more, I give the values data frame foo bar baz. So data is there itself, and if I give this data which is already there, I've just reduced it a little bit. So I'll have another frame. I'll just take the data from the above there, but I'll just remove. I'll drop my name. I don't want name in this data. I'm taking this data, but I'm not taking name. 1 minute, I'll just show you which data I'm taking. This data, same data, but I'm not taking name now. So I'm just converting that and displaying. Age and rating is there. Now it's only integers. And then you can see the pivot. I'll just remove this pivot from here actually. We'll do the pivoting later. Let me display the data only, and then I'll put the pivot here. And age columns is rating. You can see this now. Age is 23. It is sorted automatically. Common things, if 30 is there again, so it won't be coming again. It won't be displayed again. Only selected, only unique values are there. In a pivot table, unique values are always displayed. Nothing else is there. Okay. Now let's work on few other things. We have function, min function, max function, and all. We can just use this on the data frame. Okay, we have TF, so we'll be using on this only. So other functions which I had given actually. Minimum is min, so m is equal to, we have df dot min, the data I have. So I already have the data, so I'll just print minimum 23 and rating is 2.56. Let's see, 23 is the minimum and 2.56 is the minimum. 2.98, it should be here somewhere. 2.56 here. Okay, fine. 2.56. Yeah. Minimum function we have, then we can find the absolute also. What happens if I get the absolute? Absolute. Yes, I have again A is equal to TF dot ABS. Okay, I had asked you guys to do this, but you did not. This is the absolute value. Okay, so nothing will happen as such. Data frame is okay. Okay, let's find the product now. Product PR, oh, sorry, PR is equal to TF dot pro. And let me find in the PR. Let me print DF also. So product of age and rating. Multiplication, it multiplies, finds the product. Cumulative product also you can find. CPR, DF dot, that will be more meaningful actually. Or you can actually see it in a better way. Print CPR. And let's run it. See, so cumulative product is a cumulative product. It is on age and rating also, multiplying. Cumulative sum is also there, sum is also there. So cumulative sum, if you want to find, then cumulative sum CS is equal to PD, that is df dot count sum, cumulative sum, and print CS. And if I run it now, this is a cumulative sum 4.23. Let me print a df also so that you can see that. 4.23, 4.23 first will be okay. Now 3.24 and 4.23 are added there. So you can see the cumulative sum. Yeah. This is useful when we plot things. We find the cumulative sum and then we distribute the things. All are actually important. Let's find the mean value. Mean df dot mean. Oops. And m. Okay. So we have the mean now. We have age and rating. Cumulative sum, cumulative product, mean. We have the mode. You can find the mode. df dot mode, very simple. Just apply that. I was expecting you guys to do it, but my idea. This is the mode, and median also. You can find mean, mode, median, everything you can find. So you have different things you can find. Mean we have found already. Mode we have already found. So now what is left? Let's see if something is left. Cumulative product. We have found standard deviation. We have not found median. Mode we have found. Let's find the median. Median. Okay, so direct you can put on the data. And what else is left? Some we have found the sum, I think. Count. Okay. Give dot count. See. The number of records or elements in the data. Then sum is equal to df dot sum in this. Okay, I'll just put it here. Sum it and here is count, and this is your median. The sum, you can see that it has summarized the data. We have found the sum also. So mean, mode, median, and one is left. Let me see. That is your standard deviation. So let me put that also. Let me see if we have data. I'll put it on it. Right. Standard deviation. More data in this. What happened? Yes, the std I normally use, but that's okay. Std, it's already there. It's giving me some error. It's okay. Yeah, it was giving some error. That is what I was wondering. Pandas has no attribute std. It has std. It has std, no doubt about that. Standard deviation is there, very much there. Let me see. Lab can find. Yes, it may have changed, so I'll have to check. No, it is not showing me standard deviation, but it is listed actually. So, give me 1 minute. I have used it earlier, so something must have changed. We have group by on all also. It is there, but it has to be with the series or what? It has, definitely Pandas has. But you can have, if it is not there, I can try with NumPy. 1 minute. NumPy we have np.std. Let's. It is saying that missing one required positional argument A. It needs a different data. It requires only one. Let me try with this. I'll put some data and see. 4, 3, 8, 6, 17, 18, 19, 24, 27. Okay, I'll have to use group by or something like that. Okay. So it requires only, it can work on only one column. So if I give only one, then it will work. It's okay. So here we have given this some data and the standard deviation we have calculated, but we are using here NumPy. So your Pandas is not working on that. So we don't have anything as such in Pandas. But this is something interesting because it is there in Pandas. But it is only up to changing the data basically. But it should work. I'll have to create a series. Let me see if I can work on this with Pandas also. I'm not sure, but let me try. I'll have to convert it into series, I think, and then I can find the standard deviation. I don't think it is going to work this way. No. So let me have S is equal to, let me convert it into series. It works on series. Let's see what we get. Okay. And on this series, if I find the standard deviation, then it should work. And then the data output, that is basically print s dot std. This should work. Yes, it is working. Okay, so 9.555 whatever. But there's a difference in the two values. What NumPy has given is 9.190, and what Pandas is giving is 9.59. This is something interesting. This is interesting. The data has changed. We have to be careful now. You have to be careful with this, that when we are using NumPy, the values are different, and when we are using Pandas, to convert it to, it works on series only. So on series, we can find it directly, but then output is not the same. This is interesting. Okay, we have something. Let's see this one. If we have non-values, what happens? Series will, I'll take SR and then I'll print SR.std. The non-values, that is non-values. So it finds that. Absolutely no issues. So it can find on that also. It works on the series actually. Okay, it may be possible that there may be a duplicate value. No, there is no duplicate value. Yes, there is no duplicate value. The series actually eliminates the duplicate values. 1, 4, 3, 8, 6, 11, 17, 18, 19, 24, 27, and 28. Yeah, they are unique values, but still the standard deviation is different. It is something to be explored. You'll have to hunt the reason. Okay, let me see something. Okay, let me take this data which I use with name and all. Yeah, this one. This I'll take. I'm just experimenting with a few things. EF is equal to PD dot data frame E. So we know what EF is. And now let me, we have DF. Okay. And DF dot cumulative sum. Does it work? Yes, it does. You can see that it is summing up the strings also. So it adds up the strings also. And if I find, try to find this thing, df dot sum, so it adds up all the names, the age, and the rating. The string is also added. So cumulative sum, sorry, sum and cumulative sum, they both can take the strings also. So it will just add up. It will not work when I'll be using something like absolute or cumulative product. It won't work. Let me see. Not work with df dot absolute. It should throw an error. Should throw an error. Okay. See. See. Bad operand type for abs. It is not possible. So absolute value you cannot find, cannot have with the string. Even a cumulative product won't come. Let's see what we get with cumulative product. We need to play around and see. Prod. Like a product, there are many more functions that you can see. It is an error, can't multiply sequences by non-integer of type str. So you cannot do that. Right? So this will show an error. So we will keep the error so that we understand what it is. So let me share it with you so that you can have a look. First, let me share. Uh, hmm, hmm. Okay, you can open it in Colab because you have an option there. Open in Colab, and there directly you can open. Let me share the link with you. I'll put it in the message first. Then I'm putting it here in conversation also so that it stays there. And unknown Colab. Okay. Mm, I've shared it here, and let me share it on my WhatsApp group also. So we have shared. So I'll just stop the recording. It's not required.